Hello everyone, I'm happy once again to be joining you in integration and interoperability and some of the work that's being done within the ocean community to improve discovery, use, and understanding of data. I'll be talking about this through the lens of the JCOM Observations Coordination Group, of which I'm a member, and some of the work that we've been doing to approach interoperability, to approach improving interoperability within some of the different platform networks that are part of OCG. Our strategy is to provide an interoperable framework that provides data access. Rather than just putting up data portals that have data available, we would like to have a framework that leverages services like data access protocol, web mapping service, and offers machine-to-machine services to provide a framework for building data portals. We're using ERDAP as a data platform, as a recommended data platform to provide this. We also would like to improve data and metadata where it's possible. So where you have collections of observations, how can we look at that collection as a single aggregation so that we don't have to look at individual feature types in order to understand the data? And we also would like to, of course, as part of this framework, to coordinate with discovery services so that the data can be found. So discover, understand, and access is really what we're trying to improve. So I'd like to give a couple examples where we've done some work in a couple different ocean communities, the Ocean Sites community and the Drifting Buoy community. So the Ocean Sites time series, there's several of these reference time series that are out there observing phenomena in the ocean. We had a small proposal to focus on a handful of these moorings to provide sort of an integrated long time series from the moorings. So each mooring has its deployment cycle, and the long time series then take those individual deployment cycles and stitch them together to make a credible time series of the data that's been observed over the lifetime of the platform. So the way Ocean Sites provides their data now is previous to this proposal, they had some individual deployment files that were available through a thread server at GDAX, which are NDBC and Ephemera. But those weren't very useful in terms of looking at the long time series because they were individual deployments and the calibrations had to be done in order to actually stitch those together. So you couldn't even really get a valid time series from those data. The folks at Woods Hole went ahead and did the science work necessary to create some files that could be individual files, and so they made it a little more difficult to look at. What we did is we took those files and we put them into an ERDAP server, and what that allows us to do is look at the whole time series very easily with one single URL to access the data. And these are the example of the Ocean Sites, NTAS Stratus, and HOTS moorings. And so what this means is that now, as a user, it's very easy for me to actually grab and use the data rather than having to go to an FTP and download 4 or 5 different files, figure out how to stitch them together in a time series. A single URL allows me to look at the time series of data. And so what we're looking at here is a user accessing the complete Stratus time series data through a Jupyter notebook, which uses Python to access data and visualize data. So from there, you can look at different time ranges that you're interested in, but what makes this really usable is that it's very easy now that we're in this interoperable framework to start comparing with other data. So for example, that green line that hopefully you can see on this plot is actually the GRIS satellite data. This is also available through an ERDAP, so it makes it very easy for these two things to interact. So a user can quite easily grab the data and start comparing it. Now, the Global Drifter program was a little different. They have, 1,500 surface drifters that drift along and measure data. And what we wanted to do is not only improve the data, but allow us to look at this whole collection as a single entity, as a single feature, rather than individual surface drifters. Now, the data that the formats that they were using were a bit more, which is fine in and of itself, but they had two data files. One that was a metadata file, which described the observations, and one that was a data file, which then actually had the data. So from an outside user's perspective, it'd be difficult to kind of tie these two things together in order to get a very coherent look at the data. So one of the things we're working on is actually creating a netcdf file that merges the metadata and the data into one single file. That still has the issue of having individual features for each drifter platform. So what we can do once we have those files is we can put those again into an ERDAP server, and this allows us to look at the entire collection of drifter data. So now we can see all of the drifters through one single easy to access URL. What this also means is that we can start hooking these data streams up to higher level access services or and analysis services. This is the live access server. It's hooked to the drifting buoy data that I just showed you. It means we're able to use these higher level tools to drill down into the data and learn more about the data very easily. And in fact, other clients are quite easily prepared to and can currently connect to ERDAP, grab the data, use the data. So it's quite an easy to use framework for many clients and clients that people are already familiar with. And in fact, if we go back to that notebook where we had the Stratus data with the GRIS data, now that the drifter data is also in ERDAP, again, it's another single couple commands to grab the URL and plot the data. And now we're looking at the data from the drifters plotted over the other as well. And so this plays into what's very popular topic right now, and that is that of essential ocean variables. Goose has defined these essential ocean variables that cover physical and BGC data, but for greater understanding, we really need to integrate across the different networks that are measuring these, and supporting interoperable frameworks can help make this actually happen. So for example, here's an ERDAP server. Now, all these data that we have collected are in this ERDAP server, and the uniformity of that data allows us to very easily put together a data set with an integrated view of that temperature data. So with one simple, easy command, I'm grabbing this integrated view of data rather than having to go to 8 different places, download, format, reformat, try to understand the data or what's happening. So this is very quick explanation, I understand, and I apologize for that, but the interoperable frameworks and the data platforms such as ERDAP help us to move toward this path of supporting EOVs. Now, there's a lot more to discuss about this. How do you harmonize data from these heterogeneous sources? You need to make sure the metadata is very clear and very detailed, so you understand what the source of the data was. And there are products out there like GlodeApp and the World Ocean Database that are doing things like these, and it seems like it's a good idea to try and support those and make those better and make those sufficient for EOVs. And I think it's also important to provide both the essential ocean variable as an integrated product, but also the individual products that went into it, because people will want to investigate how those products were created and possibly even create their own. And so basically, what I'm trying to say is data is very important. I think of it as a key performance indicator in terms of flow, how much data is flowing, especially when we're talking about the real-time system, how much of that data is getting into forecast models, etc. How much of that data is available for access and use, and really how can we track the impacts and things like digital object identifiers, which are citable and allow people to cite the data sets they used, are really things that can go a long way to helping us provide impact. And the Surface Ocean CO2 Carbon Atlas project that we heard about earlier is one of the great examples, because we can actually track the impact of that data because of the DOIs, because of the hard work of the data team there. We know who's using the data and what impact it's having, and I think that's very important. A lot of people want to know what their data is impacting and who's using it. So I apologize, that was a very quick run through, but I want to thank Benjamin for the opportunity, and I hope everyone enjoys the meeting, and I'm happy to answer any questions through email that anyone may have. Thank you very much.